this question. So let's say I have an example graph over here, where my x0 and y0 are my initial values. I will then need to first draw a tangent line at my y0 value. And let's say I need to find y1. So I'll approximately put my x1 value somewhere along here. Now the distance between x1 and x0 will be known as h, or our step size. And ideally, our approximation point must be as close as to the curve as much as possible. So if let's say my h value is bigger, since my approximation point will be further away from the graph, it will then be less accurate. So in this case, to find x1, I will need to add x0 and h together. Now I need to find what is y1, which is y0 plus this small distance here. Now, we know that this is a right angle triangle, so then we can use rise over run, where hxy is equivalent to this vertical distance over h, which then gives me hfxy. So my y1 value would then be y0 plus hfx0 and y0. And let's say I need to find what is y2 and x2. We need to move our x values in equal intervals, so the distance between x2 and x1 is also h, and x2 is basically just x1 plus h. And for our y2 value, we will need to draw another tangent at our y1. Same thing, you get another right angle triangle, thus we can also use rise over run again, where this time fx1 and y1 is equivalent to the vertical distance of y2 and y1 over h. After that, we will get a similar equation of y2 is equivalent to y1 plus h f x1 and y1. So based on that, we can infer that xn is equivalent to xn minus 1 plus h, and yn is equivalent to yn minus 1 plus h f x minus 1 and y minus 1. So now we are given that y0 is equals to 1, and we need to find what is y1. So using the two formulas we derived just now, and I will use a step size of 0.1. So to find our x values, let's say I want to find x1, which in this case will be x0 plus h, which gives us a value of 0.1. Or let's say I want to find x2, which is x1 plus h, which gives us a value of 0.2. And we will need to repeat this process all the way until when our x is equivalent to 1, as we need to find what is the y value when x is 1. Now we need to find our y values. So let's say I need to find what is y1, which would then be y0 plus hfx0 and y0, which gives me a value of 1.1. Or let's say I need to find y2, which is equivalent to y1 plus hfx1 and y1, which gives us this value here. And we will need to repeat this whole process until we reach our 10th step, or when x is 1, and this will give us an approximate value of 1.911. Now comparing that to our general solution method, using integration, we will get an exact value of 1.915 in 3 decimal places. And now to find our approximation error, using these two formulas here, the first one is to find the error itself, and the second one is to find the percentage. I will get 0.004 and 0.209 in 3 decimal places. So that is all for my assignment video. Thank you for watching.